Okay, let's start. Last session for today. Cool, you still are here. Yes, welcome to my presentation. It's about the future. Who is excited about the future? Yes? Okay. So, there's a lot of people that try to predict the future, and I don't want to call myself one of them, but I feel like there is things coming, and one of these things are called GraphQL and React. Or GraphQL and React, or maybe Vue.js or whatever. And I want to show you the future. I want to show you what I think we could maybe all use in maybe a year or two. And maybe also not, because we don't know what the future will bring. But let's look into it and let's maybe decide if that is something cool. So my name is Michael, or people also call me Schnitzel. It's a German name, so I'm also originally from Switzerland. I'm the CTO of Amazee, and I give presentations. So Amazee actually has a bit of history in decoupled websites. So when originally in 2013 the first decoupled websites came up, or people started to talk about decoupling websites, we as a company were actually pretty much against that. Even like one of our lead engineers even wrote blog posts about it, that headless Drupal, it's a lie. And the reasons for it that there was really bad SEO, there was a really bad accessibility, the performance was really bad. So we thought that people are jumping on it and ignore all these things that are happening around it or that it doesn't support. So for a long time we said we are not using headless because it's not where we really want it to be. And so in October 2016, how it comes, a client came to us and said, hey, I have 12 different websites. All of them are, some of them are in Drupal 6, some of them are in Typo 3, another one is custom in Symfony, and the third one is something, I don't even know the CMS anymore. But what I want, because it's a publishing website, or a publishing company in Switzerland, said, I want to build 12 different websites with 12 different front ends, but one single Drupal backend. Why? Well, we want to share content. Because in the publishing or in the media, people don't think anymore about single websites, they think about content. And one content can maybe be interesting on 3 different sites. So currently what happens, the first website writes it, and then they copy-paste the content around because there's no sharing. So what they want to do is really have multiple websites up front and at the back end, and in the back end I can just say, publish on site 1, 7, and 8. And maybe they completely have different fields, and then the images, they will magically appear all on the site. So of course we thought about, okay, let's just build 12 themes and do all at the same and use like domain module or whatever to like separate. But then we actually looked at the specifications and realized, oh, that's not going to work with the domains because the sites are so crazy different. Like you really would actually need completely different content types and things like that. So yeah, our thinking was, oh shit, like how should we do that? And of course they waived me money, interestingly enough money, that we said, okay, let's look at it. And we started to think about it. We really thought, okay, instead of running away, let's look at the problem. And we had an idea. We had the idea of building it headless, decoupled. Because in the meantime, beside of the Drupal, there's new things that came up. In the meantime, people, open source communities, looked at the problems that we also were so publicly about why we don't use headless, and they came up with things like React and Apollo and Redux, which allow you to have server-side rendering, which allow you to fix all the SEO and the accessibility problems that we talked about. And also, there's a new thing that is called GraphQL that allows you to have multiple requests at once and therefore fixes the performance problem. So we just looked at it. We created a test app with 2 different front ends and the back end. The GraphQL module we shortly implemented, we hacked it together, and it works. And today, we have 2 websites running. One of them is gomio.ch and the other one is beobachter.ch. And there will be 10 more following that do exactly that. So there's completely different front ends with 1 Drupal backend. So we're happy. We started that in October last year and we launched it during DrupalCon. Yeah, I don't launch websites in DrupalCon, but that could be another topic. But we are really happy now. And what is interesting, what's happening after the first team within Amazee starts doing something and they're excited now suddenly, we right now are implementing 8 different public websites or production-based websites that have the same stack running. So what I want to do today is look into the different components that website uses. We will use the websites as case studies, so we will actually look at them, how they behave. So we will look at GraphQL. GraphQL as in what is it? Then we look at GraphQL inside of Drupal. And then we look a bit at React. How does it even work? And all the parts together working, because at the end, we have 3 different technologies. We want to see them working, and I'm going to show you how that works. So let's look at GraphQL. Right now, GraphQL gets a lot of hype, and it's good. But let's look back where it actually comes from. GraphQL was invented by Facebook. And there is actually a very interesting story behind. It started in 2012, and now in 2015 they first published it. So you have to imagine Facebook has some content and has some users, and they want to show that to phones. So you have an iPhone app, you have an Android app, and you have a Windows app. And then you also have light apps. If you ever go to like a country where there's not good internet, you will realize Facebook.com looks completely different. Because they have a light version of Facebook that it loads less, and on every picture you can actually click on, so you can decide if you want to see the picture. So Facebook has a lot of different devices consuming data. And for example, on the iPhone app, they're launching, or they're releasing a new version of the iPhone app every 2 weeks. And they say they support the iPhone app the last 2 years. So what does it mean? There are 52 versions of Facebook iPhone apps in the wild. And all of them use different APIs. So what did they end up with? They had 52 different REST APIs. And that's only about the iPhone app. And now you add the Android, and now you add the Windows. So, because every time you build a new functionality in your iPhone app at the front, the REST API that used to communicate with the data needs to support that. But you also need to have the backwards compatibility. So you will end up having a configuration system for your API. And Facebook did that for a couple of years, and they said at one point in 2012, they said, no, we have to find something different. And they started GraphQL. GraphQL exactly works against or for these problems. And in 2015, they published some example code, and they said how it works and how it can be used. So let's look at actually a GraphQL app. So what I have here is the Star Wars API, a perfect tool to test some things, and that is now a regular REST API. And let's say I want to show a page about Luke Skywalker, and in that I want to show in all movies he was in, and I also want to show the directors of all these movies. I want to show that on one single page. And so I would start, and there's an API that gives me the people, and I know Luke Skywalker is number 1. So hey, I query the API for people 1, and in there I get Luke Skywalker back. Perfect, I see his height, his mass, and whatever. Perfect, and I can see the films that he was in. But I see not the name of the films, I see a URL. So what would my app do? It would take that URL, copy it, put it there, and load it. So oh yes, good, I get the first film. And then I get the director. Perfect. But now let's say I also want to show the birth date of that director. Now I don't even have a link. So I need to like, okay, so I need to go back, and then like, I have to find like, there is maybe an API for people. So what I will end up with is multiple requests to my API to just show Luke Skywalker his movies and the director and the birth date of the director. GraphQL goes in a completely different way at it. So there is a Star Wars API for GraphQL, and GraphQL has that awesome GraphQL API Explorer. And that's really, you don't need a documentation of the API because you can explore it yourself. So on the left side, we do our requests. We do the queries, and on the right side, we see the response. So let's go here, and I can press Control Space, and it shows me all current objects that I can query. So let's say I want to start with a person. We know that from before, okay. Now I want to say which person, so it's a parameter. So I'm opening my bracket and I see person ID. Okay, let's use that. And let's say we know from before, we know it's number 1. And let's run that, and we see there's an ID coming back. And by the way, what GraphQL did, it automatically extended my query, so it realized that, well, if you want to know the person, you probably want to know. Okay, so I say ID. But let's say, what does the person even have attributes for? And I see there's a name, okay? Let's run that. Oh, Luke Skywalker, perfect. What else could there be? We had the height, and by the made a mass, and perfect. And let's say, well, actually, I don't like mass. That's really weird. Maybe makes sense with aliens and stuff, but actually, I want to call, don't give me weight back. I want to have mass. I want to have weight back. So I can even define what I want to get back from the GraphQL API. So if in the backend, the field mass is ever going to change, I can still get weight back. It doesn't matter because, so I can define what GraphQL is instead of just loading an API and getting all the stuff back. I'm defining what I want. And the GraphQL helps me to discover that. But not only that, if we go in here, and if we go a bit down, we can see connections. So let's enter that. And GraphQL does everything automatically. That is a connection to another object, to film objects. And what do I see? I see IDs. So let's go in there, and ooh, there's a title. And I see there's a New Hope ID I don't need, actually. Let's remove that. And I can see all my, now in there, there's maybe there's a director, yes. And I can see the directors. So with one single query, I can define myself, what do I want to get back? How do I, as the consumer of the data, how do I expect the data? So instead of the back of the API forcing me to consume the data in a specific format by maybe a developer that I never talked to, I can now decide my own, what do I want to get back? That's the power of GraphQL. And the next power is, I can make multiple requests at once. Let's remove the film connection. So let's just go back to Luke Skywalker, but I can do multiple requests at once because if, by the way, I would also like to get, let's say, all planets, because why not? And I also want to see the name of that planet, and let's see what else we have. I've never used planets before, but look, there's a resident connection. Let's see what that does. And maybe, let me get the name of them. So, okay, the residents, there's no residents on these planets. Maybe they're not. So I can request multiple things at once in one single query. I don't have to make multiple requests. So my front end, if we think back about the front end as a website, I can define all my things that I want, and they will be sent to the API. The API generates me all the data and gives me back in one single request in exactly the format that I'm expecting it. So that's what Facebook fixed, because with that, it fixes a lot of problems. First of all, you get exactly back whatever you need. You, as the consumer, decide what you need. You can request multiple resources in one. If I need a lot of data, I just write a lot of queries in there, and I get them all back. One thing I didn't show you now is you can do fragments, you can do variables and all kind of things to create your queries, to reuse them and stuff like that. And that's the beauty. What we see over here is not given. GraphQL does not decide how all these objects are called. GraphQL is just how the language, how do I query something. But how they're called, you can completely define your own. So you can do any schema that fits on a Drupal site, on Star Wars, it will fit on StarCrack, it doesn't matter, you can use it anywhere. And one thing I also didn't show you, you can also do mutations. Right now we're only reading, but it also works the other way back. So I can also send stuff, and I can update stuff. So I can even update and request at the same time in case I need that. And the most beautiful thing of it, it's versionless. Because, let's go back to our easy example. If a new version of the API comes out, and now let's say I also get the hair color. And I see the hair color here, but maybe I also want to translate that. So as an API provider, I can just create a new key that is called hair color translated, for example. And everybody that never used that key doesn't care, because they don't know. At the time that they wrote it, they didn't know about that. And every future person that knows about it will use it, but it's versionless, so you never see in a GraphQL a version number, because the idea is that you just add additional functionalities to the existing object. And as long as you never change the old ones, it will be backwards compatible all the time. So what Facebook did, instead of having 52 different API versions for the REST API, they have now one single GraphQL version. And all iPhone apps are using exactly the same, just based on at that time that they used it. And it is strongly typed. If we go back, there is a documentation of endpoints. And if we go in here, and let's say we go to people, and people actually give us a person back, so you can see these fields. We have a name, it's a string. We have height, it's an integer. We have a home world, it's just a planet, so we can create our own objects or our own types. So who can guess a CMS that is strongly typed? Drupal. It's Drupal, yes. So let's use GraphQL and Drupal together. So we built a GraphQL Drupal module that has full GraphQL support out of the box. You install it, done. First, though, we really suggest you to learn GraphQL first. There is an awesome page on graphql.org/learn. It shortly explains you, in 10 minutes you will learn how to load stuff. And then the Drupal also comes with the GraphQL. So what we see here, we can also see in Drupal. We will see that later. And yes, control space is your best friend. So if you just want to know what does a person actually have, control space, and it will show you. It will automatically do that. So here's a short example. For example, we can say, okay, give me node by ID, ID number 1, and I would like to get the entity ID back and the entity type, but actually it's label, and then, for example, that will go back. So node ID 1 is label content. Super easy. We will see more examples later, but basically that's what comes out of the box with it. It has support for all entities, for all fields, and all that stuff. And you can either create your own custom schema. If you want to create an API that's a GraphQL API, and you don't want to expose all fields automatically because whatever, you can create your own schema. Because at the end, every of these things here are just objects that are tried to be loaded by the GraphQL, and so you as a programmer can decide themselves what actually comes back there. It's completely built in object-oriented, and there is an example module in the GraphQL module. Plus, we also have, we will see that later, there's an example app that has Drupal, decoupled, React, Apollo, and everything all together. And there's some demos in there. So if you want to see how to create custom schemas, we can see all that there. So the GraphQL module, it's already used in production. It comes with a default schema. You can bring your own schema. It has support for content and config entities. So if you want to expose a web form, for example, it's a config entity. A web form is not a content entity. So you can expose all the fields in a web form. It has full Drupal cache and cache tag support. So if we load a node, it will be cached internally, and the next time it will be cached. Plus, also the GraphQL response has cache tags in there. So if you have a CDN or so that supports cache tags, that works. And of course, it also supports mutations. So you can not only use the GraphQL API to read, you can also use it to write, to edit, to change. So now we have talked about the middle part, the GraphQL. We have talked about the Drupal part. Now let's go to the front end, what is actually running. In our stack right now, we're using React, which is, probably you heard about it. It's a JavaScript framework. We have Apollo. Apollo is a plugin for React, not only for React, but actually for a lot of different languages and frameworks that teaches GraphQL. So React learns GraphQL through Apollo. And Redux is a state container. So if you ever used React, you probably heard about Redux. Redux allows you to have different states and go back in states and special and crazy stuff. You don't have to learn it out of the box. It comes a lot of it, but just Apollo uses that on top. So let's go back and let's think about 2013 when we wrote our blog post and said like, ooh, SEO and accessibility does not work with decoupled websites. The reason that SEO and accessibility was so bad with decoupled apps is that what you actually got back from the server when you requested a decoupled app is you got 10 lines of HTML code back, which is an HTML and a body and a header tag and one JavaScript file that was included and nothing else, because the whole app was running in the browser. So isomorphic JavaScript or server-side rendering or fast boot or whatever, there's a lot of different names for that to the help. So what happens? In an isomorphic JavaScript world, the browser requests a page from a server. Like the start page, it's just a regular HTML request. And now, there's not a Drupal sitting, but there's actually a Node.js server sitting that renders the whole page. So the node looks at the request and sees, oh, you never visited my site before, therefore I will render the whole thing internally. So the server runs React inside itself, and then will send the whole HTML over to the browser. So the browser just receives an HTML page with CSS and things in there, like it would from Drupal right now. Drupal does exactly the same. Drupal renders the HTML in itself in PHP and sends it over to the browser, and the browser displays it. But now the isomorphic part comes. In there will be a tiny JavaScript included. And what that JavaScript will do, it will start a whole React app on the already existing HTML content that already has been rendered, and will morph the whole app into a full React app. It will take over all click events, it will take over all links and everything, and future requests will not go to the Node.js anymore, they will go directly to the API, because at that point we have a full-fledged built React app, and now we can do that. And the cool stuff is, if 4 and 5 do not work because the request is maybe a crawler or a bot that cannot run JavaScript, or is out of some kind a browser that has no JavaScript support, it will still work. Because the first request, we basically, the continuous, if you click on the link, the React has never been loaded and therefore it will still work. A lot of theory, let's look at it. So we are here on gumio.ch. As mentioned, that's one of the first sites we launched. It's if you know Gumio, it's about food, it's about chefs. So there is an article about the chef, and we see there's a picture on top. There's text here, things like that, and blah 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 blah. So let's disable JavaScript. So we go here and we disable JavaScript, and we will visit that site, and we will see it's all there. So what happens is the browser makes a request to Gumio. There's a node server there, and it renders the HTML for me as a browser. And what I'm actually getting back here, if I go here, let me run that again, just that you really believe me. So the first request, and you can see the response is HTML. So there's regular HTML that comes back. JavaScript is completely disabled at that point. There's all the React happens on the server side. So I can go here and I can click on the start page. And it will load me the start page. Again, JavaScript disabled. Let's now go back and enable JavaScript. JavaScript disabled away. And let's look at the network tab. So the first request has never seen React. Therefore, it goes to the node and it comes back and it loads. It comes preloaded with all HTML. But now, let's click on whatever, something. And now we can see that actually in here, it did not load the whole page new. There is just one single GraphQL request here that just requests a GraphQL endpoint on api.gumio.ch. As mentioned, it goes directly to the API. And what we get back is, for example, our path, and we get back an object, which is a node with titles and stuff. And we can see that one fits that. So it's a GraphQL request that goes to the API, and it's rendered by GraphQL. So right now, that is a full GraphQL app with every single click. It's handled by React with Apollo, with GraphQL. There's no page reload, nothing at all. So what is really cool, if, for example, I go back to the start page, loads me the start page, I go back to the menu, and I click on here, you see it's instantly loaded. Because now Apollo, for example, realizes that that GraphQL request has already been done once, and it uses the request that got back that has been cached, and it's loaded immediately. There's no request anymore. So I could now disconnect my phone that gives me my internet right now, and I can click around on the website, because the whole thing is now cached. So it's a regular React app. So that was the first thing that we said. The second one, we said performance is an issue. In the past, when you had decoupled websites, every single piece of the site had to be loaded by separate requests. And as mentioned, GraphQL can now do multiple ones. So let's look at that as well. So React, Apollo, and Redux keep everything in an internal cache, and GraphQL itself can load multiple resources in a single request. So let's go to that. So on here, we have a map. And you can see, after the map is loaded, there is no footer here, because why should there be a footer on a map? So let's look at the GraphQL request here. We search for GraphQL. So if I now click on, sorry, I have to do it again. If I now click on Gumio, what I would expect, or I need to load the footer. And so what happens if I click here, there is a GraphQL request here that now also requests the footer, and we can see there is footer primary menu loaded by GraphQL because React realized the footer has never been rendered, so it goes back to React, loads the footer beside of the start page. That is the request for the start page. But now let's click on, let's say, that article, and let's look at that GraphQL request here. and you can see the footer is gone. Because React realizes that the footer is already loaded, so why should I request that again? And will only load really what is necessary. And that's a huge performance boost, because first, if I need to load a lot of stuff, I can do that. I can contain multiple requests in one. But if I don't need that, I don't need to request it. In a world where we only had REST APIs, that would have never been possible. Obviously, though, we'll talk about Node.js server-side stuff. So that means we need to run something also on the server. So the hosting part of that is slightly more complex. So what happens here, we have here the regular Drupal stack. We have a Drupal module installed with GraphQL. No special deal. But we also have a Node.js. So we have a Node server running that runs inside a Docker stack. And what happens is the browser itself requests HTML. That's the first request. That one goes to Node.js directly. Node.js will pre-render everything. Node.js does GraphQL requests itself. It runs React in itself on the server. So Node.js will make GraphQL requests to the Drupal API and will return everything through the HTML. In the browser, if JavaScript is enabled in the browser, it will morph into a full JavaScript app, or the React app, and starting after that, the browser will just make requests to the Drupal GraphQL directly. And the images, just for completeness, they go to the Drupal all the time, because they're created by Drupal anyway. So what we basically need is we need another Node server running, and I'm actually talking about a Node server. It's not, that cannot be done by PHP. You need Node.js running on a server, so that makes the whole thing a bit more complicated. Now, during the last presentation I gave that somebody asked, okay, and how does it actually look for the 12 websites? And there's no caching in there. So that's how it looks for 2 sites, only 2 of 12, for the actual production. So first of all, what happens, first we have everything cached in a CDN. So the HTML is cached in a CDN. That HTML will go to a Node.js server that we saw before. That one will make a GraphQL request that goes again through a CDN that caches the GraphQL request that goes to the Drupal. And when the HTML comes back, the browser will also make a request that will also go through a CDN, the same as here actually, and the images will also go. Plus, all the cache response, they all have cache tags in there. So if in Drupal, somebody goes in there and edits a node, the Drupal will connect to 3 CDNs and will clear these cache tags, so that the next time when somebody visits the site, it's cached everywhere. And what we basically do is we do that for every site. So here we have all of that here we have running for the first site, and all of that here we have running for the second site. So all we have to do is we just need to clone that stack a second time, a third time, a fourth time, because the Node.js is going to be completely different. But the backend is exactly the same. So let's look at these sites. As I mentioned, the first one was Gumio, and the second one is Beobachter. And you can see they look completely different. For example, the teasers on Gumio have a picture, a title, and a teaser text. On Beobachter, they only have a picture and a teaser text. The menu structure is completely different. We have like submenus. They don't exist over at Gumio. But at the end, they run on the same Drupal. So what happens is it all is via GraphQL, and the GraphQL of each of the Node.js frontends decide what do I need back from Drupal. Drupal will generate it and will show it. Okay, so we looked at the different parts, and I know it's not that easy. It's slightly bit complicated. So we said, okay, let's generate something that allows all of you to run that today. How can we make that? So we created a starter kit called Drupal decoupled app. You will find it on Fubi's GitHub repository. He's actually the lead that wrote the article that the headless Drupal, the cake is a lie. So let's look at that. So if you go there on Fubi/Drupal decoupled app, it's a Git repository, and we can see we have a backend and a frontend. And it explains you in a short amount what you actually have to do. You have to clone it. We run Composer install on the backend. It's a Drupal, so we run everything Composer. On the front end, it's a Node, so we run. You update. If you've been at the presentation before, at Amazee, we all use Docker Compose YAML files. You install the site with one single command, and we're running. So we've already done that, so we don't have to wait for that. So what I have back, what I have back here, I have my decoupled backend. That's a Drupal 8, and let's go and add a new article here. So I'm adding an article, Hello Texas Camp. And because it's a live demo, we're never sure. So that's just the Drupal backend. You can actually see the frontend is still there. You can still use that even on a decoupled app. It's just not going to look nice, but that's perfectly fine. And now let's go to the actual decoupled. So the decoupled runs on another port that runs via Yarn. So it's another node server that runs. And what it will do, it will, and we have an article overview here. And if we can see here, we can see there is Hello Texas Camp there. I can click on that, and I can see will it work in here. We also have another node in here. And if you have the Apollo, React, and Redux, they all have Chrome dev tools. So what will happen is that you believe me, this is actually a React. So we can see that we have all these different, like this is an article teaser React component with styled components. And we also have an Apollo. And if we go back here, we can see that Apollo actually does GraphQL requests. So if we go here in queries, we can see that that there was a query generated, and Apollo actually brings me the GraphQL directly in there, so I can see what type of, now you can see that they have fragments and they have variables, so that's a bit more complicated GraphQL than what we saw before. But if let's say I click on Hello Texas Camp, and we can see here that it actually does a route request with a path that comes from that variable, and it tells it, give me the title and the body back, and this is what will be rendered here. So you can download that, you can start today, and you can start playing with it. It's all there, it's all installed. You can start doing it. And if that you really believe me, if we look at the node source of what actually comes back from the node, server-side rendering is disabled right now here. You can enable it with one single environment variable, but we want to make sure that we can test both. You can actually see that's a full React app in 16 lines of code with a lot of trimmed non-mite space. But it actually is a full decoupled, so everything will run locally on the computer. You can play with it, you can try it out, you can even install it on existing sites and start using your React and GraphQL. So basically that's it. As a short resume, it was a high initial investment. So everything I showed you, we didn't have nothing in October. We maybe had a tiny GraphQL module that was able to return some things. There was no React, no Apollo, nothing at all. But we really believe that now is the time to use these tools. And it's still the case that you need a high initial investment. But we are really committed to open source everything that we build. So the GraphQL module is on Drupal.org. All the additional node stuff you can find on our GitHub. And we will open source everything, because our idea is to bring the initial investment down. It should be really easy for anybody to start using it without needing to learn all the craziness. And if we go back to the developers, they are in love, because now it makes sense. We actually, on the teams, on the 12 websites that I talked to you about, at one point, we had a front-end team and a back-end team, and they had one sync meeting a week. where they talked about the GraphQL API, slightly changes that are maybe necessary, but beside of that, it worked completely independent. The backend team built huge migrations from Typo 3 into Drupal, and the frontend team made sure to style all the things, and they worked the same. But they were able to completely work different. And now we launched 2 sites, and the next 2s are running, and there are 2 teams that are implementing both sites completely independent, but using the same Drupal backend. The clients, of course, they have not only a super fast website, but also a site that they can change anytime. They can change something on the front end without needing to be worried that this will affect any of the other sites, because it's independent code, but still using the same Drupal backend. And as I asked you about before, we're very excited about the future, because there's going to come more, and we will continue to open source everything. We will continue to write blog posts, make presentations if anything is new about it. And yeah, basically that's it. That's the future. Questions?
Yeah, 2-part question. Obviously, this thing has some kind of authentication thing, like OAuth or something that's preventing anyone from going to your servers. And
we have full Drupal security support.
Okay.
So if you send a Drupal cookie, a session cookie with it, it will authenticate you, and all the queries will all checked against your Drupal user session. So if you don't have access to a field, you will not see that field in GraphQL.
Okay. The second question is just a little bit related. You can build your own Open Graph server, right? I mean, this is almost like exposing your entire. You can figure out what data you want to expose, and you can just do an OpenQL server, and you can build a very robust API for anyone to use.
Yes, and that's the cool part, is you could change it any time, as long as you don't change the existing keys. As long as you add new keys to the GraphQL, you can continue working on it. And that's the reason why, for example, GitHub decided to use a GraphQL API. So GitHub has the REST API, but they also have a GraphQL API now. And that's also the reason why a lot of other companies are deciding to use GraphQL, because especially in a situation where the consumer and the builder of the API do not talk with each other, you need a good interface, and GraphQL brings that.
Is there any examples out there of commercial websites that are providing GraphQL interfaces for people?
It depends if you should be able to see them or not.
Right.
So what happens if you look at Facebook, you will actually never see a GraphQL request, exactly out of the reason they want to prevent that just their API is fully open.
Right.
Because if we go back to our situation here, I can do loops. So I could say, let's say I go here and I go to one of the connections, so film connection. So I'm getting back like the name, no, sorry. And now, and in here, there is like a character connection. And now I have a person again. So what I can do now, I can take my person and I take my film connection from before and I paste that in there. And I can continue doing that. And what will happen on the backend side, it will start like generating huge amounts of data. So GraphQL, as powerful as it is, it can also be easily used to DDoS. So you need some ways to prevent it.
You can't just open it up to the world.
You can. It's just a question how long it's going to take that somebody realizes. So what Facebook does, for example, what we also do, if we go back to here and actually do a request, instead of, let's say let's go to Network tab, GraphQL. Let's say we request that thingy here. If we look at the GraphQL request, we can see that not actually all elements are requested. It's just a GET request, and we can see some versioning here, and we can see an ID. It's not very nicely shown, but we can see ID 5. So what we do is every possible GraphQL request that can be sent by the React, and because of the nature of React, you can generate them. You can go through React and figure out all possible GraphQL requests that can ever be done. They are hashed and sent to the Drupal. And now, instead of making the full GraphQL requests, I'm just sending it over which version and which ID I want, and Drupal will know what exactly I'm going back. And if you inspect Facebook requests, you will see exactly the same. So with that, we actually don't expose the full GraphQL API into the world. That's also in the decoupled app. If you want to see how that works, you will find it all there. It happens fully automatically, but it's one way to protect yourself to somebody. But if you search for GitHub GraphQL, you can actually see here that GitHub has now GraphQL, and there is, you have to request early access right now, but then you will get full access. And they give you the API full on, but they have, every request that comes in, they have an analyzer, a complexity analyzer, and if it's too complex, they will tell you, no, sorry, I can't do that. So there's the other way around, that you have like some code that prevents that first.
No loops.
Yes, no loops. Behind.
Okay. So when you're building something like REST, so for instance, I created something with Vue.js instead of React. So I have a challenge with the image styles. So how you solve the image styles in GraphQL? Because if you for other people, like if you query the image is gonna give you the original one. It's super huge, and you don't want that for performance, right?
So in React, when you load the image component, React tells actually Drupal which image style it would expect.
So that is going to live in the JavaScript side?
Yes, yes. So that's one of the parts where the front end has to talk to the back end. That's one of the sync meetings I talked about, is they had to discuss like what type of image cache or image styles are needed to be created in the backend. But as mentioned, we can actually also expose config entities. So, and we can also create config entities. So if you have a situation where on the front end you have no idea what type of image style you want to get back, you could do that. The other way that at that project we're talking about is to maybe completely abandon image styles of Drupal and use an external tool. Like, for example, Fastly just announced that they will have image, like basically they make image style as a service. So that in the request that you load an image, you say, I automatically want to have it cropped to that size. So you don't tell Drupal anymore what actually should happen. So there's both approaches we go right now, is to either that somehow the front end can talk to the Drupal and vice versa, or not using image styles in Drupal at all anymore.
So every time you need a special size in the images, so you declare that new image style in the React code, right?
You need to define it in the React code and in the Drupal image style. Or you could take an existing image style and just crop it again in React. Not actually cropping the image, but like, so that's one of the parts that is a bit hard, yeah. I think in the Gummi and the Beobachter we have 55 different image styles right now, exactly out of that problem.
So along those same lines, are we shifting our thinking about caching and page performance completely from the Drupal side to the React side and whatever CDN we're sitting on top of or something like that?
When you have such a site that is completely decoupled, performance is mostly going to be about the React performance itself. Because the React, or the GraphQL, the GraphQL requests in here, we can see they are 338 milliseconds. For example, the React request, or the GraphQL request for the whole front page. So the whole performance part will actually happen inside of GraphQL, inside of React and there.
But is that hitting the Drupal backend that has page caching turned off? And so that's with live database requests and everything?
It depends. So that one, you can see that this one has not been cached by the CDN, mostly because that website is not really used from the US. So, and just the CDNs and POP here. Drupal itself, though, has full page cache and also the page cache installed, yes, or enabled, and therefore will cache. So everything in here, like these things, they will all be cached inside of Drupal. So there might be some requests to the database, but there should actually not really be, no.
So Drupal's page caching will be a performance assist underneath GraphQL. Like GraphQL requests will run faster if Drupal's page caching is turned on.
Correct, because at the end what happens is Drupal, if like here where I load, so this is a super easy example of requesting a node. So what I say, I want to have a route, and I want to use node/1 entity, and then I want to have a fragment, and the fragment gives me back the title and the body. So this will use all of Drupal's caching mechanisms in terms of entity caching and all that stuff. So yes, all of that has to be enabled, or Drupal will load it automatically. But the page or the cache for that entity internally will use cache tags again, so that when I go and edit that node, it will clear the internal Drupal page cache, but it will also clear the CDN in the case if the CDN is connected, yes. So yeah, if we go back here, and so as mentioned right now, the GraphQL, so if I go back to the start page, and I click on that, why don't I see the GraphQL now? Let me reload. So we have the GraphQL here, which was 600 milliseconds. Now I go back to the start page. It was 350 milliseconds. Now I go back there. Now it's not even loaded. So that's the beauty of it. Now if I click back and forth, the site is instantly, because it's not really reloaded anymore. But if I do this a couple of times, at one point, yeah, I still have misses, so I can't right now recreate the front end. But you see, it's not, yeah, it's between 300 milliseconds. And that's really the idea. For us, the GraphQL requests should be below 500 milliseconds all the time.
So these were done using individual REST requests?
Yes.
Have you done like any performance? Have any of your clients asked you to, I guess they wouldn't care about what's going on under the hood necessarily, but...
I mean, look at that. That is the GraphQL request. So for example, we load here, that's a video about, that's a recipe. So you can see that's a recipe with the chef who created that, with the ingredients and the explanation, plus more stuff. And if you look at the actual GraphQL requests, so we would first load the recipe, which is that object. And then in there, we have a chief cook, which is the person. So that would be a second one. And in there, we have like a name about her, and then a teaser image, which itself has multiple sizes because we need that image multiple times. So that would be 3 requests again. And then we have instructions. Okay, that's just a paragraph. But we have like an organization, which itself would be another request. So there's not even a need for that. Like, and then, yeah, so we have related recipes, even better. So, and in here, we would have like all these other things. So it would, at least for that page, we would probably talk about 10 to 15 requests. And even the TCP handshakes take longer than the whole request, the whole single request. So
and you'd be doing a Drupal bootstrap on every REST request? Is that
yes,
true?
yes. And GraphQL does one.
Okay.
And actually, if you request multiple things, Drupal will create in itself sub-requests that do not create another bootstrap. So it will be much, much, much faster. That's how we get to like 300 milliseconds with Drupal actually returning like a request that has a lot of like connections and stuff like that. Yes.
I was wondering if you had an opinion on how GraphQL compares to JSON API.
A lot. It's really the two, I wouldn't say like competitors right now, but they both try to solve the same problems of the possibility of loading relationships of objects. One of the, I personally believe, because of that, it is much easier to write GraphQL than JSON API. Because JSON API does not have such a thing. The syntax of JSON API, in my opinion, is much more complicated to understand. If I never have worked with an API before, with JSON API, I have to read the documentation about it. I have to learn about the parameters that I can inject. In here, I literally go here and say like, okay, what do I want? And I say, okay, I want to have probably, show me just all vehicles that are there. And I want to see, please, all names. And I can see all vehicles and I can learn, okay, that's a vehicle. And with JSON API, that's not possible. The next thing that is not possible with JSON API is that inside, with one request, I can start to complete independent requests. So here, so I can say, on top, I want to have, let's go back to the person. ID is 1. And I want to have the name of that person. No. It's called person ID. That's the thing. So that you can't do with JSON API. What I'm doing here, I'm starting a request and saying, give me the person back, and the person is called, give me the name back, and then I can also create another request that is actually all vehicles. And if I think, well, actually that is a bit weird, I want to create 2 completely different requests, I can make named queries. So I can say, I call that vehicles, and I put that in there, and that one is called Luke, and I can run both of them inside one, and I can get multiple requests in one back. And with JSON API, that would create 2 different requests back, and that's really a bit the difference right now.
I was just wondering, and I'm going to look at the demo app, but are you generally able to copy and paste the queries you're writing here into your React app? As like, you come up with a query, you like it, now you can just paste that?
Pretty much, yes. It's just that in React, you never actually write the whole GraphQL query, because each component in React defines its own GraphQL part. So if you write, like here, that overview that we saw before, that one here, if we look into Apollo, let's look into the queries that are actually given. So you can see here we have an article overview query which loads the overview. But the internal things, that one here, is actually, that is actually a component called article teaser. So the article teaser decides its own GraphQL query again, because only the article teaser knows it wants to show the title and the body. That's probably what it is. So what React and Apollo will do, you can see here the title and the body. That one is actually given by the article teasing component that is injected into the article overview component. So when you write the article teaser, you never know that you are actually shown on an overview. So if you use the article teaser on another node or somewhere else, you don't have to worry about that. So React will, every time that it should render something, it goes through all the components that there should be, extracts all the GraphQL fragments out of there, puts it all together in one big GraphQL, that's what we see here, sends it over, it comes back, and it will take out all the pieces again, inject all the data into the single components, and they will all render. Yeah. Yeah, so you, if you look, I mean, we can look at it, we have the time for it. So let's look at the decoupled app. Let's open the front end here. So if you ever seen the React, that will be very similar. So we have here, we have our app, we have the components, we have the article overview. Where is the teaser? Somewhere there should be a teaser. Ah, here. So in article teaser, you can see the teaser only describes its own fragment. And the article overview describes its part of the GraphQL and will just say, hey, actually inject in there the article teaser fragment, and that is just how it is defined. And that's an easy one. And if we go back to the full app, there's multiple components that define their GraphQL. And the most awesome part is, in here, it can happen that the same component is rendered twice. Technically can happen. Like, that teaser could end up, out of any reason, down here again. And React realizes that and only makes the request once and gives the component twice, and it just takes the response back and shows it twice. So it handles all the caching and the other stuff for you automatically. Okay, we're over time. If you have more questions, I'm around the whole day tomorrow. Or if you really feel pressured and want to answer a question, then I can do that.
I wonder if you had an example on your sites that you did of doing a mutation, doing a write update.
Yes, but I need an account that I don't have right now. But there is one. There is a commenting functionality that uses GraphQL requests for writing comments. Yes. So yes, I'm around. If you have questions, whatever, hit me, and I'm happy to answer them. Thank you.